All right, so we're talking about trigonometric functions and the signs in the different quadrants. So if everything in quadrant 1 is positive, in quadrant 2 you have sine and its reciprocal positive, but all the rest will be negative. So that means that cosine, tangent, cotangent, and secant will all be negative in quadrant 2. So only the two that I list here are the positive ones, and the rest in that quadrant would be negative. So you will find problems that look like this. So this question says sine of theta is greater than 0, tangent of theta is less than 0. What quadrant is theta in? So we're saying that the sine of the angle is positive, the tangent of the angle is negative. So then we have to determine what quadrant theta is. So what I do for this type of problem is I look at each of these individually and I say, okay, I ask myself, for which quadrants is the sign positive? And so let me label my quadrants here. And the sign is going to be positive in quadrant 1, and the sign will be positive in quadrant 2. And then I go to the next one, and I say to myself, where is the tangent negative? Well, tangent is going to be negative in quadrant 2, because everything but sine and cosine sine and cosecant are positive. Everything else is negative. And tangent is positive in quadrant 3. Tangent is positive in quadrant 1. So tangent will be negative here because everything but cosine and secant is going to be negative. So in order for both of these statements to be true, then you are looking at quadrant 2. So the answer here would be quadrant 2. So you have to kind of look at it and see which one do both of these statements are true for. Also, we use that to evaluate trig functions like this. So for example, when we're finding reference angles. So, but first let's talk about what a reference angle is and how to find it. So let's look at the 4 quadrants. And so a reference angle is the smallest positive acute angle that is formed by the terminal side of the angle and the x-axis. So, but here's my x-axis. So, for example, we could have an angle that is like this. This is what we are used to seeing. An angle that has the initial side here, and then it terminates in quadrant 1. This is the angle that is an acute angle. But no matter where our angle falls, so if this is our angle falls into quadrant 2, this is our angle. And now our reference angle would be this part. And it's indicated by this notation. I want to make sure I use the correct notation our book uses. Some books use a single quote and call it theta prime. Our books use theta with this little line above it to indicate the reference angle. So that's our reference angle. It is think about the definition. Let me write it on here. It is the acute angle. Remember what's an acute angle? An acute angle is an angle that's between 0 and 90 degrees that is formed with the let's say by, formed by the terminal side of theta. The terminal side is the end where the angle ends, and the x-axis. So this would be an example of a reference angle in quadrant 2. Let's draw a reference angle for each of the quadrants. So in quadrant 1, it's the reference angle is the same as the angle because that's already an acute angle. But if your angle would fall into quadrant 3, here's your angle, and your reference angle would be this small portion. And if your angle was to fall into quadrant 4, so let's say this was the angle, so this is theta, then this small portion is your reference angle. So how can you calculate your reference angle? Each quadrant has its own formula. So if your angle falls into quadrant 1, we already mentioned this, the reference angle is the same as the original angle. But if your, so this is quadrant 2, if your angle falls into quadrant 2, then you calculate your reference angle by taking 180 and subtracting theta. And this is the degree formula. If it would be in radians, you would take pi, because pi is equivalent to 180, and subtract theta. In quadrant 3, if your reference angle falls in quadrant 3, then the formula for the reference angle would be theta minus 180. If you're talking about in terms of radians, if your angle's in radians, you subtract pi from the original angle. So I'm giving you both here because throughout the chapter, you're going to see both types of angles. You'll see some in degrees and some in radians. And then lastly, if your angle, the original angle falls in quadrant 4, then your formula for the reference angle would be equal to 360 and then subtract the original angle. And if it is in radians, the reference angle 360 is equivalent to 2 pi, so you would take 2 pi and subtract the angle. So now that we have all those reference angle formulas, we are going to use it to evaluate a trig function. So let's say that the question says, find the sine of 240 degrees. Well, the first thing I'm going to do is find the reference angle. Because if my angle is not an acute angle, this is the first thing I need to do. Find a reference angle. If it's not between 0 and 90. So the reference angle here, 240, where does that fall? So if I take a look at my quadrants, this is 0 degrees, this is 90 degrees, this is 180, this is 270. Move my screen a little bit. This is 270, and the last here is 360. A complete circle goes 360 degrees around. So in this particular one, my angle would fall somewhere here. The terminal side for 240 degrees would fall into quadrant 3. So that means that I'm going to use the reference angle formula. This is I take the angle and I subtract 180. Now, just to put this on the board here, if you're talking about radian measures, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. And then when you get back to 360, it's 2 pi. So, finding the reference angle for this particular problem would mean that I'm going to take the angle of 240 degrees, subtract 180 degrees, and my reference angle is equal to 60 degrees. And then after I do that, I'm going to evaluate the function at 60 degrees. So that means I'm going to take and find the sine of 60 degrees. So the sine of 60 degrees, now there's a few ways we can find the sine of 60. One of them is to use the special triangles. So this is a special triangle. It has a 30-degree angle, 60-degree angle, and a 90-degree angle. And the special triangle has these ratios on their side. 1 square root of 3, 2. This is called a special triangle. It's called the 30, 60, 90 special triangle. It is formed from an equilateral triangle with sides of 2. And so an equilateral triangle looks like this, where you've got 3 equal sides, 3 equal angles. And hypothetically, if you had all those sides equal to 2, because equilateral triangles, and so this is part of geometry, if you bisect this angle, do a perpendicular bisector, then it would get rid of this portion. So this would go away. And it cuts the bottom in half. So now instead of having 2, you would have 1 here. You'd have 2 here. It would cut this angle in half because an equilateral triangle has 3 equal angles of 60, 60, 60. And then you can find this by using the Pythagorean theorem, and it ends up to be square root of 3. So just a little background on that, but that's not really our trigonometry. That's getting that special triangle. So 60 degrees is here. So the sine is the opposite over the hypotenuse. So we're going to say that that would be the square root of 3 over 2, because this would be opposite, this would be adjacent, and this would be hypotenuse. So now that we have that, that is the sine of 60. But I need to know, is it positive or negative? Because you're going to determine, so I should write determine, if it's positive or negative by the quadrant. And so this is in quadrant 3, and in quadrant 3, sine is negative. And so that means that my answer would be square root of 3 over 2. So this is how you do trig functions for angles that are not acute using that definition of a trig function that we talked about. And the other stipulation here is if you had an angle that is negative, the first thing you'd want to do is find the coterminal angle. So I'm just going to put that up here. If angle is negative, find the coterminal angle. Finding the coterminal angle is finding an angle that is 360 degrees away. That you want to find an angle that is in the range of 0 to 360 to work with. All right, so that's our answer.